You're recording now. Please make a start on the do now. It should hopefully be on your screens. You have 5 minutes for the do now. There's slight issues with the do now presenting. For some reason, my screen isn't sharing properly with your screen. Let me just try and restart this. Apologies, guys. Aha. Here we go. Should be fine now. Sorry, I had two of the same PowerPoints up at the same time, and I obviously shared the wrong one. Now you have 5 minutes to do the do now. Question 5 is to write that as the product of its prime factors. So a factor tree. Apologies, that question isn't finished off. A minute left. Okay, I'm going to finish off in 5, 4, 3, 2, and 1. Perfect. So, question one is 1, 2, 3, 4, and 12. Question two is 5. Question 3 is 4.8. Question 4 is 500 millimeters squared. That's not the correct answer for question 5 because I said product of prime factors, which would be 140 can be 10 times 14. 14 would be 7 times 2. So 2 squared times 5 times 7 for question 5. And the star question is 87.5%. Sorry about question 5. I'll make sure there's no mistakes next week. So today we're doing volume and surface area, mainly of cubes and cuboids. So again, same as last week, ideally something to write down on. Obviously, for the do now, you would have needed that. But again, if I'm going too slow or too fast, so I know that all of you can join us. You can watch us back on YouTube. Sorry, it's a bit late last week. But it'll be on hopefully a bit sooner this week. So, some new learning. So here's a net of the cuboid. I want to find out the total surface area of the net. Remember to have your mutes mics, your mics muted, please. My cuboid has 6 faces that we looked at last week. Has 6 faces. So to find out the surface area, I need to find out the combined area of all 6 faces. So the area, this one, this one, this one, this one, and the top and the bottom one. So what I'm going to do, I'm going to start off by working out section by section. For the cuboid, we're given the lengths 3, 5, and 4. You only have 3 different lengths on a cuboid. And we're given 3, 5, and 4. So because I know those ones, I can also work out the remaining ones which I've just shown up with blue here. So if this is 4 here, all these lengths going across here will also be 4. If this one's 3, the one that's going to meet up with this side is going to be 3. That'll be the same edge of the cuboid that we're thinking about from last week with edges, vertices, and faces. And every single one of these widths would be 5 as well. Everything on this side would meet up with this side, so we should create an edge for the cuboid. So again, this is 5, and it makes every single one of these lengths the longest length. 5 for every one of those rectangles. So all I need to do then, I know how to work out the area of a rectangle. I just do base times height. So my top and bottom of my cuboid is going to be 15 centimeters squared. So I've got 2 identical faces. So I have 2 lots of 15 centimeters squared. These 2 here, which should be the front and the back of the cuboid. My base is going to be 5, my height is going to be 4. So again, 5 times 4 is 20, and I've got 2 identical faces for that. And then finally, I've got my two smaller rectangles here, which is 4 by 3. These would be your two sides, either side. So 3 times 4 is 12, and 3 times 4 is 12. Now, to find out the total surface area, I simply just have to add together the area of the 6 faces together. So, another way of doing this, I've got 2 lots of 15, I've got 2 lots of 20, and I've got 2 lots of 12. So I can just do 2 times 15, 2 times 20, and 2 times 12 and add those bits together. However, you can just literally do 15 plus 15 plus 20 plus 20 plus 12 plus 12, whatever suits you. You get the correct answer either way. So my total surface area is 94 centimeters squared. So here's the same example here. So 94 centimeters squared. So this is what my 3D cuboid would look like if this is all folded together to form the 3D shape. This is what it would look like. So again, that 20 centimeters squared was for the front and for the back. There's the two identical congruent rectangles, and we're 12 for each side, 3 by 4. Again, I've got two identical congruent rectangles, and the top and bottom, that was 5 times 3, which is my 15, 15, which is my top and bottom. It's, again, two identical congruent rectangles. Yeah, just so I'm labeling the sides there so you can see where all this information has come from. So 2 lots of 15, 2 lots of 20, and 2 lots of 12. So the sides, top, bottom, and front and back. And that is called finding the surface area of a cuboid. Finding the area of all 6 sides and adding them together. You might want to write down a note in your work booklet to help you with some of these questions on these pages, that the surface area is the total area of all faces of a 3D solid. So I know it's quite, you might be following through now, go, oh, that makes sense. But later on, if you attempt the questions, you might want to just write that note down to prompt your brain to remembering what surface area actually is. So I'll leave that on there for just 15, 20 seconds in case you want to write it down. But again, you can re-watch this later on if you wish. Okay, moving forward. So calculate the surface area of this cuboid below. So again, my cuboid has 6 faces, and I've got 3 pairs of identical rectangles, which means every rectangle you can see here, we've got one exactly the same. So the front's the same as the back, the 2 sides are the same, and the top and the bottom is the same. Remember, the surface area is the total area of all the faces of a 3D solid. So I'm going to have 2 lots of the top and bottom, 2 lots of the front and back, and 2 lots of the sides. And you're only given these 3 dimensions. What I see a lot of people tend to do is just multiply those 3 together. That's working out the volume, not the area, not the surface area. So I've seen even high GCSE students get this incorrect sometimes because they don't read the question. So top and bottom, let's have a look at that. So we don't have to draw the net like in the first example, but you can do if it helps you. So the top one there, I've got the dimensions of 1 and 2. So my base is 1, my height is 2. So what's my total area going to be? 1 times 2 is 2 millimeters squared. And remember, I've got 2 lots of those. So I'm just going to double it. That's why I'm doubling the area of each one of my sides. Great, that's our first bit. Now we're going to look at the front and the back. So this rectangle that's at the front has a width of 1 and a height of 12. How do I work out the area of that? It would be 12 times 1, base times height, even though I said height times base. So 1 times 12, base times height, and that's 12 millimeters squared. But how many of these identical rectangles do I have? I have 2. So again, I'm going to double that 12, 2 lots of that 12. And finally, my sides. So that's on the right-hand side here, and the left-hand side that you can't quite see because it's hidden behind the 3D shape. So again, this time I've got a base of 2, but my height is going to be exactly the same as the height of the front rectangle. So all the heights of these rectangles that go round the side all have exactly the same height. So it's going to be 2 times 12, which is 24 millimeters squared. That's double the area of the front rectangle. And again, I've got 2 of those. I've got 2 identical ones, so I'm going to double it. Remember, there's no harm in doing 2 plus 2 plus 12 plus 12 plus 24 plus 24. This is just generally a quicker way of doing it. So I'm going to work out all those bits and pieces. 2 times 2 is 4. 2 times 12 is 24. 2 times 24 is 48. And then I add those 3 numbers together, and I get my answer of 76 millimeters squared. That is a tiny box. Perfect. So that's how we work out surface area. So I've got a few questions that, if you have a go at now, are going to help you with your work booklet. So if you can work out the surface area of as many of these 4 shapes as you can, I'm only going to give you 4 to 5 minutes to have a go. So don't worry if you don't finish them all in that time, because remember, you can play it back and have a go again at a later time. Just my hint to you guys, these top 2 follow the same principles. So if you get those top 2 done, brilliant. But there's one down here. Just be aware of some of the numbers we're using. Okay. But yeah, 4 to 5 minutes, and I'm going to set a timer this time, as I forgot to for the do now. And that's your time up. 4 minutes has passed. If you didn't get a chance to finish all these questions, like I say, watch it back and you can have a go. We will mark the ones we have done. So the first one is 66 centimeters squared. I'm just going to show the rest of them on the screen in case some people don't want to see the answer, so they want to do it a bit later. So the second one is up on the screen. Third one is up on the screen. And finally, the fourth one is up on the screen. Perfect. Right. So moving forward. So we're now going to look at volume. So the shapes below are made of centimeters cubed, which means each of these individual cubes would be 1 centimeter by 1 centimeter by 1 centimeter. And that makes each cube 1 centimeter cubed. So with that in mind, what would the volume be? So remember, volume is the total space taken up by the 3D shape. So number one, let's have a look here. We've got 1, 2, 3, 4, 5, 6 cubes in this front layer. And how many times is that repeated? 1, 2, 3 times. So we've got 3 lots of 6 cubes. So 6 plus 6 plus 6, 6 of 18. 18 centimeters cubed. Now the one in the middle, again, we've got that 6 cubes at the front. 1, 2, 3, 4, 5, 6. And that front lot could be made up from 3 lots of 2. How many times is that repeated? This time it's only repeated twice. We've got 6 plus another 6, which is 12. 12 centimeters cubed. Notice our units this time we're using the little 3 instead of the little 2. And we're dealing with volume, we're dealing with cubic centimeters. You're times it by 3 different dimensions. So that's where this unit comes from. But with the surface area, we're only looking at the area of each face. And that's like centimeters squared, or whatever the unit is squared. And you're only dealing with 2 dimensions for that one. And now question 3, we've got 1 by 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1 lot by 9, so we've got 9 on the front layers. How many layers does it go back? It only goes back by 1, doesn't it? There's only 1 lot, so that's simply just 9 centimeters cubed. And then you can think about how many different cuboids can you make with 30 cubes. So a cuboid has to not have any gaps. So for example, if this cube in the front right corner here, top right corner there, was removed, that would no longer be a cuboid because it doesn't have 6 faces. You get an extra 3 faces from removing that. So that's something to have a think at later in your own time. Remember to keep your microphones off. So now I want to find the volume of these cuboids. So we've got 2 by 4 by 6. So the front face, we're looking at this front face here. We're going across by 4 and up by 2. So how many cubes are just in that front face? We've got 4 lots of 2, so 4 times 2 would be 8. So we've got 8 in this front layer. How many times is that repeated? It goes back 6 times. 1, 2, 3, 4, 5, 6. So we've got 6 lots of 8 cubes. So if I got 6 lots of 8 cubes, I would end up with my volume of the shape here. And we can simply do it by just multiplying our 3 digits together. So for this one here, they actually did a different approach. They found out the bottom layer, which is 4 times 6. I spoke about the front layer here, but we found the bottom layer, we've got 4 times 6, which gets us 24 cubes. That took me way too long. 24 cubes. And then we've got 2 layers of that, so we times it by 2. So it doesn't matter which way you start. You can start with the front face and times it by the depth, or the bottom times it by how tall it is. But you'll notice that when an answer 48, that 2, 4, and 6, they're all factors of whatever our answer is. So whatever your volume is, all your three dimensions are always going to be factors of your shape. So now we're removing the cubes. They're just sort of help with the visuals a little bit. So I need to find the volume of this cuboid. So we can do exactly the same thing as before. How many cubes will there be in the front layer? We've got a base of 6 and a height of 5. And so you maybe look at this shape and go, well, that height is wider than the base there. Even though that says 6 and that says 5. In maths, there's loads and loads and loads of diagrams used which are not to scale. This is just representing the cuboid. So we cannot see the layers of the cubes. How many cubes would be in the bottom layer? So let's think about the bottom layer here. So the bottom layer would be what's it all sitting on? So we've got 6 by 3. So what would the bottom layer be? Well, 6 times 3 would be 18 cubes. So you've got 18 cubes in this bottom layer here. And how high does this go? By 5. So you've got 5 layers of that 18. So we simply just have to multiply it by 5 and we get 90 millimeters cubed. 90 millimeters cubed. So you simply just multiply all the digits together. You can do it in any order, can't you? So 5 times 6, which is 30, and then 30 times by 3 is also 90 millimeters cubed. It doesn't matter which order we multiply this in. And again, 3 and 5, they're all going to be factors of our final answer. So again, as another independent task here, I'd like to have a go at. Do as many as you can do in 5 minutes. And I will time it for 5 minutes. If you have any questions about this towards the end, remember you can ask your teachers through Satchel. 5 minutes. 2 minutes left. And there's 5, 4, 3, 2, 1. Right. Feel free to finish the question that you're on. We will be going through the answers like last time. I'm going to read out the first 2 answers. But again, if you didn't have enough time to finish them all off and you want to do them later when the video is posted, then that's absolutely fine. I'll just show the answers to 3, 4, and 5. So, question 1, it was funny answer. Do 6 times 8 times 1, which gets you 48 cubic centimeters, centimeters cubed. Question 2, 5 times 8 times 3, which gets you 120 cubic centimeters. Question 3 is now on the board. The screen, not the board. Question 4 is also now on the screen. Question 5 is quite tricky, had some decimals thrown in there, but it is also now on the screen. The answer for question 5. And if anyone did the star question, that's also now shown on the screen. Give you a few moments to finish off checking their answers. Please mute your microphones. Okay, moving forwards. If you need to check any, again, look back on the video at a later time. So now we're going to just look in a little bit more depth. So we're given the volume of this cuboid, which is 30 cubic millimeters, and we need to find the height of the cuboid. So we've got like a base of 3, a depth of 2, and a height of unknown. So how can we use this information to find out the height of the cuboid? So we know that the base, the very bottom of the cuboid, the bottom layer, would be 3 times 2. And we don't know how many times that's repeated to get a height. So I've just replaced my question mark with a H for height. So 3 times 2 times something equals 30. So I know that 3 times 2 is 6, and I'm just using a bit of algebra here. So I'm just using 6H equals 30. You might think of that as 6 times by something equals 30. Either is fine. Just remember that 6h means 6 times by h. So what's the inverse operation of multiplication? The opposite operation was division, isn't it? So we can use that to try and find out how many layers I need, because we know that one layer would be 6, 2 layers would be 12, 3 layers would be 18, 4 layers would be 24, and then 5 layers would be 30 cubes. So the inverse of times by 6 would be divided by 6. So 6h divided by 6 is obviously just one lot. So 6 lots divided by 6 is one lot. And 30 divided by 6 would be 5. So our height is 5 millimeters. So it's just using exactly the same methods as before, but sort of working a little bit in reverse. Perfect. Then we now know the height is 5 millimeters. These pop up in all sorts of questions at GCSE. Quite often there'd be a multi-step question where they add this as an extra sort of mark or so in a GCSE paper, just add a bit more depth to the question. Similar problem, we've got a cuboid that's 144 cubic meters, and this time we need to find the width of the cuboid. So our height is 6, our depth goes back by 3 meters, but we don't know what the base is going to be. So we do the same thing. The width times by 3 times by 6 be 144, where the width times by 3 is like the first layer from the bottom on the way to the top. We can do a multiplication though, so we know that what 3 times 6 is, it's 18. Again, please mute your microphone. Okay, removed, gone. Okay, so we know that 18W would be 144. And that would be like one of these side layers here. If you think how many of these were repeated all the way through the shape. So all we simply have to do is divide 18W by 18, so 18 lots of something by 18 to get one lot of it, and do the same with 144. And we get the width is going to be 8 meters. And the good thing about this, we can check our answers. So we can go, well, 8 times by 3 times by 6. Does that make 144? Yes, it does. So again, we don't have that much longer left of the lesson, but if you could just have a go at one of these questions, maybe. So each cuboid here has the same volume. Find the missing length. I'll just help you out with the one in the middle. You've got all 3 dimensions there, just to speed up the process. So 20 times 12 times by half. Well, 12 times by half is 6, and then 6 times by 20 is 120. So all 4 cuboids have a volume of 120. Can you just take 1 to 2 minutes to try and find out a missing dimension, either for this first one here or second one here? If you can, do all 3, but try and just get at least one done in the next 1-2 minutes, just because I'm aware we're running out of time a little bit. And I'll just time that really quickly. Again, you can go back and look at all these questions and do them in your own time if it's going a bit too quick. And that's time up. Sorry if you're mid question. Which is 10 o'clock. We've got 5 more minutes left. So I'll just display the answers here on the screen. Obviously, I told you the bit in the middle to work out the volume of 120 centimeters cubed. And then you can use that information to work out the first cuboid on the left-hand side, which is shown on the screen. And the same on the top right now, which is shown on the screen. And the same with the bottom right, which is also shown on the screen. Perfect. Here's a quick exit ticket. So first one's to do a surface area, which is the first part of the lesson. Second one to do is just finding volume, which is the second question there. And then the one at the bottom is a bit like we just did, finding a missing length. 4 minutes, and that'll bring us to 10:05, which will be the end of this live lesson. So 4 minutes. I've just seen 1 or 2 people leave a little bit early, just remembering that the lesson does go until 5 minutes past. You wouldn't walk out of your lesson 5 minutes early. That's cool. Thank you. Thirty seconds left.
Okay.
And that is time up, as we just had another person leave. Do now answer, not do now. The exit ticket answers are now on the board, the screen, not the boards. Please mark them once you have done. What I also want you to do, because the chat function has been disabled, because it's a bit chaotic last week, could you via Satchel message your teachers saying what you got on the exit ticket? So like 2 out of 3 or 3 out of 3 or 1 out of 3, etc., etc. Just send a little message on Satchel saying, I got 1 out of 3 on my exit ticket on this week's live lesson. That'd be great. Right, I'm going to stop the recording now. Please stop requesting to take control of my computer. Okay,